Hello everybody, it's Sophia again. Today I'm for devlog episode 2. We're going to be going over inventory and how I created a Resident Evil-esque, Diablo-esque inventory system. Here it is in demonstration. It is a 6x6 inventory grid. And you can see by clicking, we can pick up stuff, and then by clicking again, we can drop it. You cannot drop it outside of the usable inventory space, and obviously you cannot drop things on top of other things. This will be a comprehensive tutorial that goes over how I'm storing information about the items, how I'm loading it into the game, how I'm adding stuff to the players for testing, all of that stuff. We're just going to look over things piecewise, and we're all going to start by looking at the JSON file. So the JSON file contains descriptions of all of the items that are going to be in my game. The format is pretty simple. This is the ID of the item. It has to be unique because it's a key value pair, right? If you had two items with the same ID, they would collide, and then the program would not know which one you were referring to. So in this case, that really awful stick figure drawing of a gun has the ID of big_gun. And then its value, as part of the key value pair, is just another dictionary that has key value pairs that describe what the gun is. Display name is just a large firearm. Description is a big gun. The size is 2x1. The position is -1, -1. I'll touch on that in a second. And then icon, the texture that it uses for storage is called gun.png. And then same thing for class A. This is a survival shooter with themes of infection, very zombie-esque, zombie-coded. So class A is the name of the medicine that you can use to reduce your infection. In the actual game, it will be an injection, but I just drew a little pill bottle because I wasn't thinking too hard about it. So the item ID is class A, and the display name is just a cure, yippee. Description, a vial of class A reduces your infection by some arbitrary amount. Obviously, there's no functionality here, it's just flavor text. The size of the class A item is 1x1. The position is -1 by -1. I'll touch on that in a second. And the icon is class A.png. So why is the position -1, -1? Because these are not the items that are in the player's inventory. These are the items that are available to the player, that are available to the game, right? You're not meant to use this as cold storage for your item. Saving the game state is later. That's a little bit more complicated, and I'm not there yet. This is just like a list. It's like an atlas kind of of all of the items that you could give to a player. So it would be full of weapons, armor, consumables, food, items for morale like books and headphones and whatever, all sorts of stuff. So what do I do with these items? Well, I created a script called item loader. This is not attached to any particular node. It's just a freestanding script. And if you go to project settings, in Godot 4, you go to globals and then autoload. You can add this script to the autoloader, which is important. You create a dictionary, and then you open the file path argument with read access. If there's no file, then there's an error, obviously. You get the file contents as text and close the file, and then do JSON.parseString to parse the JSON from the string into an actual JSON object. For those who might not know, JSON stands for JavaScript Object Notation, which is a pretty widely adopted way of storing data, especially when servers over the internet are talking to each other. And then we do some simple iteration to create a dictionary of instances of the item class, which I'll get to in a sec. We basically just loop through the all of the keys and grab the data from each key, and just for a refresher, this is the key, and then this would be the value or the data that we're getting. And then it loads the texture based on where I keep my assets. I keep them in the assets folder. You would have to change this line to do whatever you want. Make sure that you load them as a texture 2D. It's important for displaying things properly down the line. And then we create a new item where we pass it some arguments to the constructor. And then at the ID of the item, which is like big gun or class A, in the dictionary, we add that item to the dictionary. So the effect of this is that if I call item loader.getAllItems, I can subscript it with something like, if I did something like this, that gets me the item with the ID of big gun, and then I can access all of its properties like .name it's technically .displayName, .description, all of that sort. So what is the item class? So declaring a class in Godot is really, really simple, especially if you're coming from more hardcore object-oriented programming languages like Java or like C#, even Python. You declare some variables up at the top. In my particular use case, I have an ID, a display name, a description, a size, a position, and an icon. Although you should keep expandability in mind, because eventually you're going to be adding things like damage or durability or, restored health when you consume it, and item type and all sorts of stuff. And then you do an init function where you take in all of these arguments and you assign them to themselves. There's nothing fancy going on here. If you have even a little bit of experience with object-oriented programming, this should be really, really straightforward. This is just a debugging function that I use. It just displays the ID, the display name, and the description of the item in like a cute little 3-line format. And then this is important. I'm putting a pin in this, we'll get to it, but remember how I said that this doesn't represent what the player has, it represents what the player can have. We need to be able to clone items from this because of the way that Godot handles storing objects. We don't want to take the actual item from the dictionary, we want to make a copy of it. This is a reference, we're not supposed to actually use these items. So that's why you add a clone method, which it just creates a new item with the same details as the other one, same ID, display name, description, size, position, and icon, and then it returns that item. Cool. So what is next? Okay, I'm gonna switch gears and we're gonna look at the 2D overview. This is my outrageously oversized panel that I've been using. Here is the inventory node. It's just a control node, and this is what this huge inventory script is attached to. I'll get to it in a second. Back in the 2D view, there's a margin container, which just has margin set to 25 pixels, and then there's a panel within that. This panel could be a lot smaller, it could have a texture, it's not really important, it doesn't really matter, there's not a lot of functionality on this, that's writing on this panel, so it doesn't really matter too much. A lot of tutorials, I say a lot as if there's more than like 4 for this kind of inventory system, advise using grid containers. I struggled with this a lot. This is like my 5th try and I finally have something usable. Grid containers make it really, really difficult to get the larger than usual sprites, like it's fine for 1x1s, but when you have 2x1s like the big gun and 2x2s and 2x3s and 4x4s and whatever, it becomes increasingly difficult to display the textures properly. And for that reason, I don't use the grid container. We are going to handle the gridding, so to speak, programmatically. It will all happen in the code. Alright, so in this script, we declare an inventory to keep track of our player's inventory. We declare a grid size, which it says 5x5, but since things start at 0, that's actually 6x6. If you want to fix that, I can show you where. Cell size, I'm doing 64 pixels by 64 pixels. Inventory cells, that's actually vestigial, I think. We don't use that. Ah, it's vestigial. Nice, I wouldn't have caught that. Okay, we need a held item variable, and then we need these on ready for the panel, which again, the panel can be whatever you want. It doesn't matter. As long as it has a signal for GUI input, it's fine. And then we also need a floating item texture rect, that we're going to use in a little bit. To start off, the inventory needs to be invisible. So set visible to false. And then we need to call that load items method that we described back here in this file, in this auto loading script. And you pass it the whatever asset you're storing all of this in, which mine is in assets dot, or it's as items.json in assets. So you just pass it there. And then I call place item to just generate items for my character. As you can see, I'm doing item loader .get all items, biggun.clone with that clone method I talked about, and then it takes a vector 2 to determine its position of its upper left corner. So the gun goes in 0, 0, and then the pill bottle goes in 3, 3, and you can see that represented here. This is in the 0th square, or the first square, and then if we count down 0, 1, 2, 3, this is in the 3rd square, when in reality it's the 4th. And then we call this update inventory UI function. We make sure that the that clicks that happen on the inventory control node do not propagate to the rest of the game by doing mouse filter equals control.mousefilter stop. You wouldn't want to accidentally interact with something in the game or fire your weapon while your inventory is open, so this prevents that. And then we add the child floating item and set it invisible, and then on top of everything with z-index equals 10, and then we make sure that the mouse filter is ignoring to make sure that you don't accidentally click the texture rectangle. It's just meant to follow your mouse. And then we also give it a modulate, and the dot modulate with a color, this is modulating it with white. It's 111 0.5, which is 50% transparent white. It's RGBA, red, green, blue, alpha. 1 red plus 1 green plus 1 blue plus half alpha is 50% transparency white. So what does the place item function do? Great question. It takes an item and a position, and then it checks if the position is occupied. If it is, it says false. And then if it's out of bounds, if the position goes beyond the grid size in either direction, then it returns false. Otherwise, it sets the position that you passed to be the item's position, and then it appends it to this array called inventory, and then it returns true. The inventory array, a lot of tutorials for this, all like 4 that I found on the internet, recommended using a 2D array in tandem with the grid container to get that Diablo feel. But again, that makes it really hard to handle the sprite drawing for when you get to bigger things. So I don't use that. I just use an array, an unsorted array. It's just a collection. Every item has its own position value that it uses to store itself inside of an inventory. And if you recall, I said we'd get back to why it's -1. That this is why, because these items are not really meant to be anywhere. -1 is not a valid inventory position. That's why I have it set like that. But yeah, if you tried to place an item without changing the position of it, or by using its like default position, it would return false because that's out of bounds, obviously. You might want to implement some minus sign checks as well. Let me do that real quick. Okay, cool. I added some, it's position.x less than 0 or position.y less than 0. That just makes sure that you can't go out of bounds in either direction. And then, how do we know if the position is occupied? Well, it checks the item inventory array. It just iterates over the whole thing. And it takes in this position and this size vector. And basically, this huge monster of math right here is just checking if the thing that you're trying to put into your storage as a rectangle intersects with any of the various rectangles it finds in the list. So it finds some, this might be easier to illustrate. So we have your storage, and let's say we've got something here, and we have something here, and we've got a blue thing that we're trying to put in a way that would intersect with the green thing. So it's gonna check the red thing first, number 1, and it's gonna see if the desired position plus the size, which covers this whole blue area, interferes with the position and size of the red square, and it doesn't. So that one gets a check. And then it's going to check the green one second, and then it's going to find that there's a problem because the up left corner of the blue thing is the same as the up left corner of the green thing. It's this square right here. So then this would fail, and then it would return true, that the position is occupied, which would cause the place item to fail. And then the update inventory UI function is pretty simple. We just do, we go through and we remove all of the children of the panel, which again could be anything. It doesn't have to be a panel. I'm just using a panel. For child in panel.getChildren, remove the child and queue free. It just deletes all of them. And then we create the textures. This was the part that I was most excited to have figured out. We iterate over all of the inventory items. We create new texture rectangles. We set the texture of the rectangle to the item's icon. We set the custom minimum size to the item's size, which, if you remember, is just a grid-based size. It's like 2,1 times cell size, which I have set above as 6464. Sets the position to be the item's position times the cell size, which, if you remember, that's another grid-like thing of, oh, it's at 0, 0, or it's at 1, 1, but times the cell size that transitions it into pixel coordinates, which are beneficial for the graphics. And then we set a mouse filter to a mouse filter stop so that we can pick them up. And then we do GUI input.connect on item GUI input.bind texture rectangle item. It's kind of confusing, but basically we're just connecting a node signal like over here, but we're doing it manually. And then we add it as a child, right? And then later on when we re-update the UI, we drop those children and draw the whole thing again. So on the item GUI input, we got the event, the texture rectangle, and the item, right? It's bound with the item. It ships along with it. If it's a mouse down, left mouse down, and we're not holding anything, then we pick up the item by assigning held item to item, and then we remove the item from the inventory. This is a really simple function. It's just like a alias for the erase function of an array. And then we update the inventory UI to reflect this change, otherwise the visuals would not adjust. And we set the floating item's texture to the item icon, the floating item's size to the item's inventory size times the cell size to get a usable graphic, and then we set it to be visible. And then during our process function, if we have a held item, we set its position to the global mouse position minus cell size times 0.2. This is kind of an arbitrary value. You can play around with this. I had it centered earlier where I did held item dot size times cell size times 0.5, and that would put you smack in the middle. But I like the idea of you picking it up by the upper left corner, so that's why I have it at 0.2 or 0.15. I'm still tweaking it. I just really wanted to get this video and show you guys what I was working on. And then this is the last function. This is a signal. If you haven't set one of those up before, it's really simple. Open your inventory scene, click on your panel, click on node, and then click on GUI input, and then you just click connect. And then in this function, we check if it's a left click again, and if we're holding an item, we calculate what I called the pixel offset, which is the event position, so where your mouse is located, minus the panel position. Because if you remember, the panel is scooted away from the corner a little bit, and subtracting the panel position from the mouse position, which is here, gets us something in kind of a local space. We're taking the mouse position in relation to the corner of the panel rather than in relation to the origin of the world, which if you didn't do that and your inventory panel was a lot smaller, not so irrationally sized like mine is, you would be putting stuff down in your inventory way off the panel because the mouse position value would be wrong. And then we take that pixel offset, which is a vector 2, right? Because this is vector 2 minus a vector 2, and we divide it by another vector 2 to cell size, which again I have set to 64 pixels by 64 pixels. And we round that off to get a nice square value that's an integer, and it's something like 0, 0, or 1, 0, or 2, 2. And that is our desired position as an inventory grid. And if the place item is successful with the held item and the desired position, then we need to vacate our hand, so we're not holding anything. Floating item visible is set to false. And then we update the inventory UI. And all of that is to say that when we open the inventory, these are the items that I started with. I can pick them up, I drag them by the upper left corner, and I can put them down with another left click. If you want to, you could probably change this to be a drag. If you want to, you could probably add some kind of highlight under the mouse of where you're gonna drop the item to make it easier to see. A grid texture, sound effects, you know, dropping items, whatever you can think of. But anyway, as a last step, I thought it would be interesting to show you how you would go about adding a new item. So I'm gonna go to my trusty dusty Microsoft Paint, and we're gonna add a, oh, I don't even know. We're gonna add a little knife. Make a little knife. I'm gonna grab black. I'm not an artist, if you couldn't tell. I'm also drawing with my mouse. But anyway, knife. And then save as, and you just save it to your assets folder as knife.png. Go ahead and close that. Back in your items.json, we're going to, don't delete your curly brace like I just did. I'm going to call the ID will be knife. The display name will be a knife. The description will be a knife. Size, another 1, 1. Position, -1, -1. And then icon, knife.png. And then in inventory, we're going to copy this line, and we're going to call this knife 2, 2. We're just going to see what happens. Okay, guys, sorry I had to pause it. I forgot a very, very, very important line. You need to have this line, texture rectangle .expand equals true. This is in the update inventory UI function. I'll show you what happens if you forget it. Anyway, as you can see, now we have a knife. Oh, there's another bug. I'll show you how to fix that. This is the problem I was running into, but as you can see, the knife functions just like any other inventory item. We just need to fix that minor display bug. The reason why that happens is I happened to have textures that were the right size for the grid to tile nicely, but if you don't, it ends up too big, and it ends up it looks really silly. It's still a 1 by 1 item, and it still gets treated as such, but it's just huge. It's just huge. So that's why we have this line in there. And then we also want to do it for the floating item. Just throw the same line up there. This is in the ready function on the inventory script. And now hopefully, yippee, look, there we go. Yeah, so that's how you do it. This was just this wasn't meant to be a comprehensive tutorial. If that would benefit my 3 viewers, then I'll consider doing one. But yeah, until then, that's what I've got for insert devlog number 2. I'll see you all in the next one. Peace out.